Sixth graders, we're starting chapter 12. And in chapter 12, you're going to be learning a lot of vocabulary words and a lot of things that are going to apply to next year when you're starting to learn more algebra. Okay? This chapter, and especially the first lesson, is about patterns and sequence. Patterns, meaning that numbers that follow a pattern or follow a rule. I remember when I was teaching you in second grade, and we had the little box or a little chart that showed you a pattern. It was, let's see, like this. It would say rule, and then it would say plus 4, and then it would give you a chart like this, right? And then it would, on this side, it would say 3, 5, 9, and 10. And then you'd have to follow the rule, right? And so on the other side, it would be 7, and 9, 13, and 14, right?
Yep.
Remember doing that?
I do. Nope.
Yeah. That was a very simplified version of what we're talking about today. Okay? Now, we're talking about, instead of follow the rule, we're doing patterns in sequence. And we're going to be talking about function rules rather than just rules. The word function is going to help you, is going to be a vocabulary word we'll talk about. So, basically a sequence of numbers, numbers that follow a pattern. Okay? And each term in the pattern, each number in the pattern is called a term. Okay? So if we go back to our simple example, 7 is the first term. 9 is the second term. 13 is the third term. 14 is the fourth term. Okay? Each number in sequence is called a term. Alright? Then, to find the rule, which is what we're going to be doing a little bit more today, to find the rule, you have to find the common difference. If we went back to our example, and you subtracted 14 minus 10, you would get what? 4. 13 minus 9.
4.
9 minus 5.
4.
7 minus 3.
4.
See, by finding this common difference, you can find the rule. Okay? So, that'll be the first thing that you'll do when you're trying to find a rule, is to find the common difference, or subtract the numbers that are in the pattern. And then, using multiplication, division, addition, subtraction, all of those operations, you'll try to find the next one, the next term in the sequence. Okay? Let's look at some examples. Instead of, now in 6th grade, we have to use more advanced numbers. So look at this one. How would we find the common difference here? Remember what it means to find the common difference? What does it mean to find the common difference? What do we need to do? Amelia? Good. Subtract them. Yep. Put the Rubik's Cube away. Subtract them. So, go back to these numbers. Which one should we subtract? Should we subtract this way or this way? Wouldn't it make sense to start with the bigger number? Yeah, let's start with the bigger number. 3 2/3 minus 1.
2 and 2.
What is that?
2 and 2/3.
2 2/3. How about these?
Minus 1 again.
No, now we have to subtract these two. So the difference in this is 2 2/3. What's the difference in this? So 6 1/3 minus 3 2/3, which would be 5 4/3 minus 3 2/3, right? We didn't have enough pieces to take away 2, did we? So what do we have to do then? Come on, everybody.
Subtract 5, 4.
Okay, take away a whole and add 3. Right, because 3/3 would be 1 whole. We're going to add 1 whole to the 1 piece we already have. Okay? We've learned this earlier this year, back even before Christmas. We talked about adding and subtracting fractions. So then we have 5 4/3, and now we can take away 2, right?
Yep.
And that equals
2
2/3. What's the common difference? That's the common number. What's the common number? 2 2/3, right? 2 2/3 is the difference, the common difference between these two. What do you think it is for this one? 2 2/3. Are we adding 2 2/3 or subtracting 2 2/3 to get the next term?
Subtract to get.
Add it.
From 1 to 3 2/3 is to add 2 2/3, right?
Mm-hmm.
And then add 2 2/3. So what's the rule?
Add 2 2/3.
Correct. Add. So you would just write that. Add 2 2/3. If it asks for the rule, you would write add 2 2/3. Okay? Now, that's how you find the rule, or to find the next term, or the next term, or the next term. What if you have one that says find the nth term? The nth term, that's using a variable in our answer, right? A letter that stands for, in other words, the any term that we wanted to. What if we wanted the 100th term? Would you want to do this 100 times?
No.
No. There's a way then to figure out the 100th term by finding the rule. So we're going to look at this one. Find the common difference. What is it? 20,
20.
20,
20.
20. Okay. Now, how could we get, besides adding 20, what else could we do to get 40?
2 times.
20, what?
Could you add or subtract 20?
Okay. Notice that we're adding the same number. When you're adding the same number, if we added 5 plus 5 plus 5, that's the same as
5 times 3.
3 times
5.
5, right? 3 times 5. Could we use multiplication to get this term?
No.
How could we use multiplication?
Oh, times 2. Oh, I know.
20 times 2.
20 times 2, right. So we could multiply by 2. 20 times 2. How could we get this one? What times 3? 20 times 3. What is the other pattern here?
Multiplication.
Plus 1.
20 times
A number.
a number, right?
Add 1 every time.
Yeah, 20 times 4. How would we get this?
20 times 5.
Add 1.
20 times 5, right?
Yeah.
Well, what are these numbers here? 5, 4, 3, 2, 1. That's the
Term.
term number, isn't it?
Yeah.
Each of these is a term. So this is the term number 1, 2, 3, 4, 5. What if we wanted the nth term? What would we replace in our pattern? Would we replace the 20 or the number? 20 times what? Actually, I should use a dot here instead of 20 times what, Amelia? 20 times n would give us the nth term. So you replace the n with the term number, with the sequence number. Okay? Now, if it said, what's the 100th term? Where would that number go? This is the 5th term. This is the nth term. This is the... We can put the 100th term there. Right?
Yeah.
And so, instead of 20 times n, we could put 20 times 100 to get the 100th term. If you wanted to find the 100th term, what would it be? What would the value be? What's 20 times 100?
2,000.
2,000, right? The 100th term in this sequence would be 2,000.
Wow.
Because it's the term number 1 times 20. Alright? Now, there's a better way to display this. There's an easier way to display this. And it is the way that you did in 2nd grade.
Yay!
Okay?
Second grade.
Sometimes math books confuse you in the way that they write things out. What if it was written out this way? 1 this is our term, and this is our value, and it was 120, 240, 3, 4, right? N would be what? What did we say?
100.
Yeah, 20 times
N.
n, right? 100.
2,000.
You see that? Isn't that easier to display? You're still finding the common difference. 20, 20. You can still find the rule. 1 times 20 is 20. 2 times 20 is 40. 3 times 20 is 60. 4 times 20 is 80. And this is how you're going to see them more in algebra. Okay? You'll see them written out that way a little bit, but mainly this way. So if this is an easier way for you to write down when you're given a pattern, if this is an easier way for you to see it, you can just write them down like this. Okay? So let's look at your assignment for today. Look at the first one. What if you wrote it down this way? 2, 9, 16, 23. Right? This was the first term, second term, third term, fourth term. So what's the common difference? 7. Is it added or subtracted? Added 7. Add 7. Add 7. Right? So what's the rule?
7.
Add 7. Yep. Is that easier to see this way than the other way?
Yeah.
For these, it doesn't make a whole lot of difference. What if we went down to number 8? Here's number 8. The first term is 0.5. The second term is 1. The third term is 1.5. The fourth term is 2. Then it says the nth term, so we're going to have to find the nth term. Yep. What's the common difference?
Plus 0.5. Yeah, plus 0.5. Yeah.
Plus 0.5?
Yeah, plus 0.5.
Okay.
Plus 0.5.
And plus 0.5. But when we're finding the nth term, we have to use multiplication or division. Right? How else could we get 1 from 1 to 0.5?
N, I'm saying can I say the rule right now?
Sure.
N times 1/2 equals the
Yeah.
equals
Or divide by 2, right? So n times 0.5 or n divided by 2. Whenever you're finding the nth term, you'll have to use multiplication or division in it. Okay? And that's why it's helpful to see the terms written this way. Okay? All right, I think that covers all of the concepts in this. Okay? Remember to find it first, find the common differences, so subtract the terms. Okay? Then second, look for patterns in multiplication and division in order to get from the term number to the next, to its value. The term number to its value. Okay?
Yes!